Hello everybody, this is Mr. Bowman. So today we're going to be looking at the ALEKS topic, simplifying a product of radical expressions univariate. So just as a reminder, univariate mean one variable, so I only have one variable to deal with here. So in this case, x, could be y, could be z, it doesn't matter. As long as in that problem, there's only one type. So whenever we're multiplying, you want to make sure that your indices match. So in this case, they're both square roots, which is true. So I have this one times this one. Unlike when we're adding and subtracting, we don't have to worry too much about our radicands, though, because that's actually what we're going to be changing. So in this case, I don't have a coefficient for either one of my factors. If I did, however, you would just multiply those like normal. So, but I don't, so I'm going to go straight to my radicals here. So they're both square roots, so I'm just multiplying them like normal. So 5 times 15. Right? So we end up with 75. Okay, x times x to the 5th ends up being x to the 6th. Remember, you do need to keep track of your exponent rules there. So we're multiplying, so I'll add the exponents, 1 and 5, and get the square root of 75x to the 6th. Now, this is correct. That being said, we can also reduce this, though, and you always want to check to see if you can reduce something when you're done. So this is what we're going to do. We're actually going to bring this down into the square root of 75x to the 6th and break it down and try and simplify that radical afterwards. So 75 is 25 times 3. 3 is prime, but 25 is 5 times 5. So when I bring these down and put them in order, it's 3 times 5 times 5, and then there are 6 x's as well. And this is a square root, so I'm looking for pairs of matching things. So I have a pair of 5s, a pair of x's, another pair of x's, and a third pair of x's. So my representatives from each of these, so just what I mean by that is just one of whatever type they are. So those representatives get pulled out in front of the radical. So 5 times x times x times x is 5x cubed. Then inside the radical, we'll put whatever didn't have a pair. In this case, it's just a simple 3. And if you pull everything out, let's say that 3 wasn't there, you would just leave the radical off and your answer would just be 5x cubed. So, but there was there. So my final answer for this, when I simplify it, is 5x cubed square root of 3.